Okay, so today we're going to be doing quiz number 8 review. We're getting close to that quiz 12, right? Once we get to quiz 12, remember I'm going to drop another quiz. But today we are doing quiz 8, all right? And we're going to be finding the domain and range for the first two problems. Remember, domain is all the values that x covers, right? And the range is all the values that y covers. But the way I told you to think about it is for domain, think of how far to the left it goes, how far to the right it goes, in that order, okay, left to right. And then for range, it's how low does it go to how high does it go. Remember when it has like dots at the ends of the graph, if the dot is solid, you're going to put a bracket, and if it's empty, like a hollow dot, you're going to put a parenthesis. If it happens to go towards infinity, you always use parentheses, right? So make sure that you kind of know what's happening with the actual function. Now, for question number 1, the domain and the range. Okay, so what is my domain? How far left does it go? -3. And how far to the right? To 3. Okay. Does it include the -3 on the left? Yeah, you see the solid dot. So we're going to put a bracket. Does it include the +3 on the right? No, that's an open circle. So there you go. This is your domain. Okay, from left to right. It goes from -3 to 3. It does include the -3 because there's a solid dot there. It does not include the +3 because there's an empty dot there. Now, for the range, how low does the graph go? To 1, okay. And how high? To 3. Does it include the low point? No, you see an empty dot there, right? But it does include the high point. So that's your domain and your range for that graph. Okay, so hopefully you guys did it. You got it right. Look at number 2 here. Domain and range. Well, this domain, it's all found on quadrants 2 and 3 on the very left side, right? How far left? Okay, and how far right? All right, so it's pretty small, right? It's a real small amount of domain, just from -4 to -2. Now, there's no holes, right? But there's also no solid dots. But if there's no holes, that means it does include it. So I am going to put brackets around them. Because if they weren't included, there would be like a hole right there. Something like that. But we don't have that. And the range, well, the lowest it goes is -4 as well. What's the highest? A +2, right? And again, no breaks in the graph, so you are going to have brackets there. So like I said, this quiz, I mean, these questions on the quiz are not meant to like take forever. It's just observation, right? You're looking at these things, right? And you're trying to make a call as to how far left, how far right, how low to how high. Okay, does it include the left side? Does it include the right side? Does it include the low point and the high point, right? Again, for my range on number 2, notice there are no points, right? No dark circles right there anywhere, right? And also no empty circles as well. Okay, if there was an empty circle here, then for -4 you would have had a parenthesis on the range, right, for -4, and then a bracket for 2. But again, we don't have that, so we're okay. Are we okay with questions 1 and 2? All right. For this one, find the inverse of a function. Actually, do me a favor. Before we do that, I'm just curious, because I don't know if I put any of these questions. Is number 1 a is it a function? Yeah, right. The way we test it is vertical lines, right? We would draw vertical lines everywhere, and it's only going to touch once. Like I can draw a ton of them, right? And it's only going to touch once per line. So I'm just going to write right here, function. What about number 2? Yeah, that one is not going to work. Okay, because I can draw a line right through here, and you see it touches more than once, right? So not a function. I don't know if I have any of those examples, so just in case I don't, might as well have that idea just kind of reviewed really quick. I know it wasn't part of the instructions, I'm just kind of adding it on. Okay, so is it a function, yes or no? So a function, not a function. Are we okay with that part? The testing with the vertical line, right? All right, now let's go back to this. So find the inverse of the function. Now remember, to find the inverse, it takes a couple of steps, right? Step number one was you're supposed to change f of x to y. Step number two, you're supposed to change y to x and x to y. Step number three is you solve for the new y value. And then step number four is that you change whatever your y value is to the inverse function. So f inverse of x in this case. If it was a g of x, you write g inverse of x. If it was an h of x, you write h inverse of x. Okay, but this does require 4 different steps. So step number one is to rewrite, right, f of x as y. So we're going to have y equals 3x minus 3 over 2. That's step one. Step two, change y to x and x to y. So x is equal to 3y minus 3 over 2. Okay? Now you're supposed to solve for y. So let me get this 2. I'm going to throw it over there, but since it's dividing, I'm going to have to multiply it. Okay? So I'm going to multiply it times x. So that's going to be 2x is equal to 3y minus 3. I got to keep solving for y, so I'm going to move this negative 3 over. I'm going to add it. Let me kind of take it over here. So I get 2x plus 3 is equal to 3y. And then to get rid of the 3 next to the y, since 3 is multiplying it, I'm going to have to divide it out. So divide by 3, divide by 3, divided by 3. I get 2/3 x plus 1 is equal to y. So that's step 3. Again, step 3 takes very long. Well, let me not say very long, but it's the longest step out of all of them. Okay? And then the last step, step 4, is to rewrite your answer as an inverse. So now that I solve for y, instead of leaving y there, I'm going to put f inverse, bless you, of x is equal to 2/3 x plus 1. Finding inverses, guys, is not meant to be difficult, just so you know. It's not supposed to be, okay? It's supposed to be some standard steps that you should be able to do, right? We're not doing some crazy like math where you're having to recreate things, but it does require you to know the steps, right? Changing your function notation to y, changing x to y, y to x, solving for y, so that's transformation stuff, and then just rewriting your y value as an inverse notation. That's all very basic stuff, but it's 4 different steps. So if you don't know the 4 steps, you might wonder, like, where do I start, right? So make sure that you guys practice this, right? Make sure you know, like, okay, I got to do this, do this, do this, and do that, right? So they always said, like before, they don't tell us this now, but they say, like, kids learn if you give them specific steps to do all the time, right? So I don't know if that's really true. When I was in high school, we didn't learn by steps. We learned by example. So you kind of saw them over and over again. You're like, okay, I think I get how to do this. Like, we created our own steps. And then now they really encourage us to give you steps. That's why I'll write them down, right? 'Cause some people like to do them like that. All right. So questions 4 and 5. So after this, we'll have 6, 7, and 8. 7 and 8 are both substitution. I think 6 is graphing. But questions 4 and 5, all they want to know is how many solutions do they have. Now, that goes back to the list. I told you that when you look at equations, you can tell how many solutions they might have. They might have 1 solution, no solutions, or infinitely many solutions. And I gave you definitions as to how to tell, right? That was section, I think it was 3.1. I'll double check right now. Let me just check. Hold on. I'm going to really quick go away, but I think it was at the very top of 3.1. Yeah, right there. The way you know it has 1 solution, the lines are not parallel. If they have no solutions, they'll be parallel, but with different y-intercepts. The b value will be different. Infinitely many if they're parallel and the b values are the same. Okay? So I wrote that before. So here we go. So these are supposed to be like really quick. Okay? If they're not solved for y, make sure you solve them for y. But I think the ones I'm giving you on your quiz are already solved for y. Just try to make it a little bit easier on you guys. Look at number 4. If you focus on the slopes, okay, are these parallel lines? No, their slopes are different. So that means they have how many solutions? Just one. If they're not parallel, one. That's it. So I'm just going to write one solution. Look at number 5. Are these parallel? Yeah, 1/4, 1/4. So your options are either no solution or infinitely many. Okay? Well, if it has infinitely many, that means the b value is the same. Do they have the same b value? No. So then that means that they're parallel lines without matching b values, so that leads to no solutions. Okay? No solutions for this. Again, this is not hard. It's just, do you remember the definitions? Because if you know the definitions, these are easy to do. Right? I can look at the slopes and say, oh, 4, slopes are different, not parallel, one solution. Right? Or slopes are the same. Well, are they the same lines? No, they're not. That means they're parallel lines. Okay? If the b values are the same, that means that they're exactly the same lines, so that means they intersect at every point, infinitely many solutions. Right? But you have to remember the definition. If you don't know the definitions, you're basically got a 33% chance of guessing. Okay, which isn't terrible chances, but you know. But yeah, make sure you guys know the definitions for how to figure this out. All right, I have one of these where we're going to graph. Now the fact that I'm giving them to you solve for y makes me think that you're not going to have to do that on the quiz. All right, so on your quiz they will be already solved for y, so you don't have to worry about doing that. As I mentioned before I recorded, again, the red and the green is for the line, so you guys will know which line is which. So let's start off with the red line here for me. Y is equal to 5x plus 3, okay? So I'm going to go up to positive 3, okay? And according to my slope, which is a 5, right? My slope, m is equal to 5 over 1, right? I'm supposed to go up 5 and to the right once, but notice my graph ends. So remember, if your graph ends, then you just do the complete opposite. Instead of up 5 and once to the right, so instead of up and to the right, go down and to the left. So down 5, left once. So 1, 2, 3, 4, 5, left once. Then if you're not sure if you did it right, from left to right, see if your slope is 5 over 1. So look, I'm going to have to go from this new point up 1, 2, 3, 4, 5, and over 1. So this right here would be 5, and that's 1. Okay, so it is the right slope. Okay, so let me just connect the dots. Notice I'm not letting the computer cheat for me here. Okay, I'm going to try my best to draw a nice straight line without using a straight edge, so like an ID card or something like that. All right, let's do the green line. The green line is beginning at -3, so here's -3. And then my slope is -1 over 1, right? M is -1 over 1. So 1 down, 1 to the right. So if I draw the line straight here, the cross is right there. Okay, that point appears to be, what's that, -1, -2. And there you go. I'm done with that one. So that's my solution. So again, try your best to draw it as best as possible. If I would have used a ruler, I'm sure I would have done a better job. If I would have let the computer generate the perfect line for me, it would have looked a lot nicer too. But I mean, this is the way I would have done it in high school. I didn't carry around a ruler with myself all the time. I think it was like my senior year when I was finally having to use rulers, because I was doing a lot of graphing and stuff. But most of the stuff I ever did was freehand, or else I used to get like a piece of paper and fold it like 6 times, nice and thick, so that the edge of it was really obvious, and then I just hold it down and use that as a ruler sometimes. Because we didn't have ID cards back then; they didn't exist. I guess they did, but not in high schools. Now everybody has an ID card. Um, so, are we good with this one? Just graphing, no big deal. For well, they're on the left side. I had to go left from 0, 0. I had to go left once, right? Yeah, so it'd be -1, and then -2. Yeah, +1, -2 would be right there. All right, so the last two are substitution problems. Okay. So I want to do 2 of these. I could just do 1 and then be like, we're done, but I just want to go over 2 of these. So when you're doing substitution, these have, 5 steps, right? Again, you don't have to memorize all the steps. Just know, like, there's a lot of steps, right? Step 1 is to write them side by side. Well, that's done. Step 2, pick an equation you want to solve for and decide which variable you're solving for. So which equation do you guys want to pick as the easier equation, left or right? Left. Which variable? Y? We could do either, right? Because they both have a 1. It could be x, it could be y. You know what? I think the next one we're going to go with x. So let's go with y for this one. If I remember correctly, the next one, the best choice is going to be an x. But let's go ahead and go with y. So I'm going to move the x over here. Whoops. So I get y equal to -x plus 1. So this is step 2, like figuring out what I'm solving for and solving it. And I'm going to get this value, and I'm going to plug that in over here. So I get 3x plus 3 times y, which would be -x plus 1. As usual, I'm just changing the ink so it can be obvious what I'm doing. And then I'm going to distribute everything. So I got 3x minus 3x plus 3 equals to 4. Okay, what do I do at this point? 3 equals 4, because what happens to the 3 x's? Yeah, they're gone, right? So I get 3 is equal to 4. So when your variables disappear, the question you ask yourself is, well, is that true or is that false? 3 is equal to 4? That's false. If it's false, what do I write? No solution. Okay, if it's true, you're going to write infinitely many solutions. Okay? But since it's false, you're going to write no solution. So initially, I was going to be done here. But then when I saw this, I'm like, okay, that's good, but I never showed them what it looks like when you actually do solve something, right? So that's number 8 showed up a little bit later on in the morning after I wrote this out. Are we okay with this one? Yeah. So I mean, the other problems are going to be the same, just that will continue, okay? Because the x's won't disappear. So here's the last one for today. We got x plus 2y equals -4, and -5x minus 3y is equal to 6. We got 2 different equations, right? Step 1 is to separate them. There you go. Already done for you. Step 2 is to pick the equation that you want to solve for, okay? So if I were you, I'd pick left, right? And which letter is easiest? X, because y has a number, x does not, right? So we're going to solve for x. So what I'm going to do, I'm going to get this 2y. I'm throwing it over there. So x is equal to -2y minus 4. So I know that everywhere I see the letter x in the other equation, I can replace it with a -2y minus 4. So that's going to go right there where the x is. So -5. X is -2y minus 4, and minus 3y equals 6. So I'm going to go ahead and distribute. Negative 5 times negative 2 is a positive 10, so that's 10y. Positive 20 minus 3y equals to 6. And then 10y minus 3y gives me my 7y plus 20 equals to 6. And then I'm going to subtract 20 on both sides. So 7y is equal to negative 14. Now I divide both sides by 7, which is going to give me an answer of y equal to negative 2. So there's one of my answers. Okay, now I plug it back into the other, or not the other, but the original equation, right? So I'm going to get this information, and I'm going to plug it in right there with the y values. So I'll get x equals to negative 2 times negative 2 minus 4. Negative 2 times negative 2 is a positive 4 minus 4. So x is 0. So my final answer, remember, you're supposed to solve for both letters and then write them as a point. Remember, x is first, y goes second. I've had a lot of students tell me, like, sometimes they forget which one goes first. I tell them alphabetical order, right? X, y, right? Even calculus, when we use points A, B, it's A first, B second, not B, comma, A. That's actually called the inverse, but that's besides the point. X, y, okay, so 0, negative 2. This is going to be your solution. The only one that we did not do was the one that's infinitely many solutions, but that's going to be like example 7, just that instead of a false, it's going to say true. Okay, and if it says true, that's IMS. All right, so that's the review for today.